Hello and good evening everyone. Now, what are we going to study today? Alright, let's see. Okay, so we will study something called exponents, and let's take an example to understand that what are exponents exactly. So let's say we have 2 raised to 3. So what does 2 raised to 3 mean actually? So now this part over here, generally this is called base, and the part above, which we call raised to, it's actually called exponent, or sometimes it's also called index. Now let's try to understand and play with this, that what does 2 raised to 3 mean. Now I'll take a different example and probably will relate that what does that mean. So let's take a different example, which is like 2 times 3. Now when I have 2 times 3 and we have this multiplication symbol, we want to represent in a way that 2 is adding to itself 3 times. So let's say I have like 2 chocolates and it's keep on adding 3 times. So I'll just say, okay, it's 2 plus 2, 4 plus 2, 6. Now this is a case of 2 times 3. But what happens when I have 2 raised to 3? So in case of exponents, we usually write it and understand it in a way that this same number 2, which is the base, it keeps on repeating. But the only difference from multiplication is that in multiplication, we actually keep on adding, that is repeated addition, but over here we do repeated multiplication. That is, the same number keeps on multiplying. Now the question might be that how many times should we multiply? So this exponent over here, which we also call index sometimes, so that indicates that it's 3, so we have to write it 3 times and multiply instead of addition. Now probably if I want to represent it visually, what does it mean? So let's try to explore. So I'll just rub this, and if I rub and make some space, let's try to explore that if it was, let's say, not 2 raised to 3, had it been 2 raised to 1, so what would that be like? So let's say I'll make some space over here and I'll write 2 raised to 1. So 2 raised to 1 essentially means that this 2 will be written just once. Now, can I represent it pictorially? So yes, let's try. So let's take, I have this lovely apples with me, and I'll write them just 2 times because over here I have just once. So I'll just write once. Now let's say had I got to a next number, which was 2 raised to 2. So what does it mean? That this exponent indicates that this 2 I'll write 2 times. I'll write 2 times, but now I'm going to multiply them. Now what could this also be? This could also be like 2 times, and I'll put a bracket over here. So probably you can relate it in a way that it's 2 times, and this can also be written as 2 raised to 1. Now you would ask that why I'm writing 1. Well, there is a fact that as we know that any number, let's say 3, if we don't add any sign to it, but we have discussed this in earlier lectures, that if somebody comes to our door, we don't judge them by saying, okay, he seems negative by his clothes or appearance. We assume, yeah, this guy is positive. So since this is positive, we assume that if any number, it does not has a sign, so we assume that would be positive if it's not representing. Similarly, if any number, if it does not has any exponent or index, we assume that that exponent would be 1. So having this little bit of knowledge, probably I'll write this into the form 2 times 2 raised to 1. And what was 2 raised to 1? It was nothing but 2. And this means that these 2 apples over here actually would be double. So instead of writing 2 2 apples, probably I would want to make double of those apples. So what I'll do is that I'll make this space over here, and instead of writing 2 apples, I'll write these apples 2 times, that is they are now double. So now we get, okay, so we had first 1 and 2 apples, and now we got 2 plus 2, total 4 apples. Now what if in next level I would have got, instead of 2 raised to 2, what if I would have got 2 raised to 3? So yes, my exponent now changed to 3. So let's try to split it again and understand. So this would be 2 times, and 2 times what? It would be 2 times 2 multiplied 2. So this means that these two will come 3 times, that is 1, 2, 3, and they're getting multiplied to each other. Now why I put this in bracket is for a reason, that I want to emphasize over here that this part actually represents this part over here above. So whatever apples I'll get, essentially they will be double of this part. So if I have over here 4 apples, so over here in the next level, what I'm being asked, that I need to double that. So in exponents we keep on increasing at an exponent rate. So what I'll do, considering that 2 times 2 gave me 4 apples over here, and over here we'll have double. So first I'll write this set, which is this set. I'll write 1, 2, 3, 4, and now when I need to double it, what it means is that this is one set, and double means that I'll write this again like 2 times. So I'll write same set again, and when this set has got doubled from above, I'll just count the number of apples, which are like 1, 2, 3, 4, 5, 6, 7, 8. Okay, so probably what I can say, that 2 raised to 3 will give me 8 apples. Now what can we make a relation? Probably we can make a relation that 2 raised to 1 will give me a certain number, but when the exponent or index is increasing, my value is increasing at a high rate, and when further is increasing, then my value is increasing at a very high rate. So as and when my exponents keep on increasing, so values will also increase at a very high rate. Now let's take example that where do we find exponents in our real life. Now let's go back to our story over here. So we have this beautiful planet. Oh my god, what is this planet? So this is Earth. We also call Mother Earth. Now why do we call it Mother Earth? Because this is a planet which has been nourishing us, which has been valuing us, and unfortunately we are dumping Mother Earth with plastic, with a lot of artificial things which is not needed. Now if it's our mother, probably we want to understand and help it be as it is. Now coming back, this Mother Earth has been supported by someone. Oh, what is it? It's burning, I think. Oh, it's sun. Now it's not only burning, it's providing us the most valuable thing, which is like energy, the solar energy. So they also have, I see, a particular distance. Now what kind of distance is it? Let's try to write and understand at what distance this is. So I'll make some space over here, a nice and good amount of space, and the distance which is mentioned, I'll just try to write and understand that how can we take that into an exponential form. Now this distance is 1, 4, 9, comma 6, 0, 0, comma 0, 0, 0, and at last one more comma and 0, 0, 0. And let's confirm 149, 600, 3 zeros and 3 more zeros, and this is huge number. Now what's the unit? The unit over here is meters. So probably I'll write it this way, and if this number has to be written again and again and again in my notebook, yeah, I understand that it's going to be very difficult. So probably exponents will come to my rescue, and I try to make it simple using exponents. Now how can I make it simple? So probably I'll see, okay, so probably I'll write it this way: 149,600,000, and these last three numbers, that's last three zero, it can be dealt with. So probably what I can do, that I can write them as kilo. Why kilo? Because we know that 1 kilo has actually three zeros and can be represented as 1000. For example, if I have 1 kg, so I essentially mean is, what I mean is that it's 1000 grams. So this kilo essentially means that it's of the value 1000. So probably instead of these three zeros which represent 1000, I'll prefer to write a K. So yeah, now is my value reduced? Yeah, very nice. It's reduced to a certain extent. But let's try to see further that where is this taking me. So I also have the distance from moon to earth, which is like 384. Let's write it. The distance from moon to the earth is, I'll also write distance from moon to earth is 384,467 kilometers. Now what does it mean that these many kilometers is what a distance from moon to earth, 384,467. Now if you want to read it, how do we read it? We know the simple reading method. It's ones, tens, 100, 1000, 10,000 lakhs. So roughly 3,84,467 kilometers. Now can I convert it back into meters? Well, let's try. So the same technique we'll use. All right, 384,467. And what was the value of kilo? Yes, the value of kilo is 1000. So if I just add three zeros or simply multiply, I'm going to get its value back into meters. But yes, my number would increase that way. So probably let's try to go and see that what do I have in the story further. So I see that the sun is giving energy to my school, and there are some rays, and I also see these light rays have something called speed. And how much would that speed be? So let's try to see, if I have a sun and that sun is giving light, so how much would be the speed of light that way? So let's try to make a sun over here. I have the sun over here, beautiful sun, and it's giving me a light, actually a lot of light, and this light has some speed. Now how much would that speed be? It's mentioned it's 3. The speed is equal to 3, and how many zeros? 1, 2, 3, 4, 5, 6, 7, 8. So it's 1, 2, 3, 4, 5, 6, 7, 8, and there's a unit. Guess what? The unit is meters per second. So what it means essentially is that these many meters, 3 and times 10 zeros, it's traveling those many meters in just like this, a fraction of a second. It's traveling that fast. Now isn't that amazing? Now what happens is that if I keep on writing in this way, my calculations might become difficult. So probably I'll try to see if I can reduce my way of writing. Now for that I need to go to this chart and take its help. Now what does it teach me, this chart? It teaches me something called prefix notations over here. And I will come back to what we were discussing, but let's also take some knowledge about prefix notations. So let's say I'm going for a job and I'm getting some kind of salary. So let's say I'm getting my salary as 20K. A real life example, I'm getting salary as 20K, and somebody asked me how much salary you're getting, and I said, oh, I'm getting 20K. So somebody saying, oh my god, you're taking 20 kilo potato. Is that my salary? That in my salary I'm getting 20 kilo potato? Oh no, I'm not getting potatoes. I won't get my family potatoes. in the form of salary. So what will I do? Oh, so probably we did not understand. Probably we were thinking that kilos were always like weight. No, kilos mean the value 1000. So when somebody says that your salary is 20k, it means 20 kilo, and kilo essentially means times 1000. That is, you have to multiply by 1000. So this means you are getting 20,000 rupees or dollar, whichever you may be working in. So that currency, rupees or dollar, is what in the form of you are getting as a money, but this kilo represents times 1000. Now, having said that, we also have other prefix notations than kilo. Let's say I have this favorite letter. Let's say we know that 1 meter, we know 1 meter is equal to how many? They're like 100 centimeters. They are 100 centimeters. Now what does centi mean? So as per our prefix notations, we know centi, and somebody said century. So do you mean that it's 100? So what should I do? Shall I like write 100 into 100? Is that what you want? Well, no, it's centi, and centi is a constant. It has a specific value. Like we have variables whose values can change. Over here we have constants. So centi is a constant, and its value is not 100. Its value is actually 1 upon 100. Now what does it mean, 1 upon 100? So this 1 upon 100 means that if I'm eating a chocolate, and by the way, I love chocolates. Who doesn't like it? So if I'm eating chocolate and by my ignorance, I happen to drop a piece of it. And who comes when you drop chocolate? Who comes first? Yes, little ants. They're very smart. They come over here. And you know the qualities of ants. When they reach somewhere, they don't eat it alone. Why? Because they have this value called sharing. And not even sharing, caring. So they will get everyone, their aunts, their uncles, their brother, their sisters, who not, they will get everyone, and they want to share this little piece of chocolate. And guess what? If 100 ants come over here and they're all taking little, and they're all taking it and sharing equally, because ants know how to share equally. Unfortunately, humans do not, but yes, ants know. So probably we may want to learn from ants, who were probably our best teachers. So over here, if they're sharing it equally, so if 100 ants are coming, how much part would each get? The simplest question of fraction, how much part would each get? So we'll say, okay, how many chocolates? 1 chocolate. So I'll write, okay, 1 chocolate being shared equally among 100 ants. So yes, I got 1 out of 100. And guess what? This is what centi represents. So 1 meter is equal to 100 centimeters, and centi is 1 upon 100. Now what about this letter, which is very similar to meter but is not meter? And let's understand. So that can be understood by the scale. If I have 0 to 1, let's say I'm magnifying 0 to 1 centimeters, and it has how many divisions? It has, by the way, 10 divisions, like 1, 2, 3, 4, 5 at the center, yeah? 6, 7, 8, 9, and 10 over here. So if I have 0 to 1 centimeters, so how much this small little portion would be? The small little portion would be essentially 1 millimeter. Now the most confusing part over here is that we study all around, I mean day and night, we finish our school, but there's a lot of confusion that why these two ends are coming together. So you say, oh, but the first one is milli and the second one is meter, but both look the same. But what is the value of milli? So let's try to see what is the value of this little word milli. So we go back to our chart of prefix notation, and we do know that the first prefix notation was actually deca, which is like times 10. And when you go below that, obviously you're getting deci, which is like upon 100. And then you go centi. And when you go below centi, that is where you get milli. So like in centi, we do upon 100. In milli, actually, we will do upon 1000. Now, how beautiful is it? And let's see how could this be taken further. Now over here I see human hair. Now I seem to be looking like a human, and currently I have a cap, but what about my hair, this hair over here? So how thick would this be? So I know, according to this chart, that my hair is very thin. Now how thin would that be? So let's try to rub and make some space, and let's try to make my little brother over here so that we can see how much his hair could be. So let's try to make this guy, and let's see how much hair this has got. So it said that the thickness of the hair is 0.005 centimeters. 0.005 centimeters. Now the unit used is centimeters. How can I convert that into meter? So okay, I need to understand, for converting into meter, I need to take the value of centi. And what was the value of centi? Come back to our chart. Okay, I got it is 1 upon 100. So it is 1 upon 100. And so what I'll do, I'll multiply it with 0.005. So let me make some space over here, and I'll write simply 0.005 times 1 upon 100, and this remaining unit is actually the unit. So what was centi if m was the unit? Well, I thought centimeter was the unit, and then I thought kilometer was the unit. But what was the actual unit? The actual unit is, my friends, not centi, not kilo. The actual unit is meters. Meter is the unit of length. So what does these do? Centi or milli or kilo, they are actually some things which modify the value, which update the value, and they are actually called modifiers, and they're constants. If you times, like 1000 times, if you multiply, that's kilo. If you divide by 100, that's centi. And similarly over here, when you divide it, so you get 5 and 2 zeros, and again you shift it 2 places back, so it would be 0.00 meter. Now one thing to understand when we are talking about exponents, that can we, instead of writing 1 upon 100, instead of writing 1 upon 1000, can we do something else to make it exciting? I think yes, we can try. So now I'll rub it over here. And let's see if I can make some sense with the division part of exponents. So what I may want to do is, actually I'll write 10, and 10 is 10 raised to 1, and I'll write 10 is I'll write 100, it's 10 raised to 2, and I'll write 1000, and it's 10 raised to 3. So what it means essentially is that this 10 means 10 raised to exponent 1, and this 100 is 10 raised to exponent 2, and this 1000 is 10 raised to exponent 3. Now when we know we are studying, sometimes we are bound to say 10 raised to power of 1. We are bound to say 10 raised to second power, 10 raised to third power. Well, but you should know that the power is not 1, the power is not 2, the power is not 3. Unfortunately, we are saying them power. So you may want to ask that what is power? So let's clarify. If I'm writing 10 raised to 3, traditionally, if we split it in a certain way, so we know that this base is the one which we are working on, and when we are saying raised to, that is something called exponent or index, but the final value which you're getting 1000, actually that used to be called as power. But you say, but we learned that it's 10 raised to power 3. Yes, because many times when you say a lie, you say 1000 times, 10,000 times, a lakh times, that becomes truth. But if you search, so we understand that traditionally this final value was a power, and when we kept on saying 10 raised to power 3, 10 raised to power 2, 10 raised to power 1, obviously I'll say, okay, you have the power. But does it really get the power? If I say I'm Superman, will I become Superman? No, I will be what I am. So we should understand that traditionally people used to say the final value as the power after multiplication. But since we kept on saying, so yes, you may want to say it's 10 raised to power 3, no issues, but you should remember that actually the power lies within, not without. And similarly, there are a lot of things in life we need to learn. Now let's say I would go back to my rules because it's time to close the class, but let me tell you some rules before I close, otherwise you'll say we did not learn anything, but I promise you we'll learn before we close. So now talking about some rules, and rules are very important. So let's see what rules do we have. So the first rule of exponents which we have, essentially it is a raised to m times a raised to n. Now what it means is that if a is a number like 1 or 2 or 3 and we call it the base, we call it the base. If a is any number, and let's take the example I'm taking like 2 raised to 3, and I'm again writing 2, and let's say raised to 5. So I have 2 as my common base. This as my common base. I can say common base. Now since I have a common base, so what it means is, according to this rule, that its value will come out to be the sum of the exponents. So what I do is that I'll write this a just as once, and I'll put a bracket if I want to, otherwise not. But I do want to take the sum of the exponents. So I'll write a raised to m times a raised to n equals to a raised to n plus n. So in this example, if we see, it would be 2 raised to 3 into 2 raised to 5. It should be 2 raised to 3 plus 5, which should be 2 raised to 8. Now can we verify this? Yes, we can. Let's take a simpler example to save time. So if I have like 2 raised to 1 times 2 raised to 2. So as per this, you can say example, we'll say that base is common. So I'll write this 1, and this would be 1 plus 2. So I'll write, okay, so this would means it would be 2 raised to 1 plus 2 is 3. And what if I take the left hand side as well to solve? So what I'm going to do, I'm going to solve the left hand side separately, and I'm going to solve the right hand side separately. So this means it is 2 times, and we know 2 raised to 2 is 2 times 2, which is 2 into 2, 4, 4 to the 8, and same over here, I get 2 raised to 3 means I multiply 3 times, that is 2 times 2 times 2, which is nothing but equal to 8. So since I get both as same, we can say, okay, this rule satisfies. So this is my first rule, which we use many times. Now what if we have a second rule as well? So let's try to rub this, and the only change in the second rule is that you will have a little bit of difference in the exponents. Now what that difference might be, let's say I get up in the morning, I'm very nice, and somebody comes and crash my car. So I was very happy, and now I'm very sad, so I shout. So that is a little difference, that some negativity might come in me. So let's see what happens.